So let's pick up with where we left off. We were talking about mutually exclusive events and how we handle this. So when you see the word or, you always want to ask yourself if those events are mutually exclusive. That's a really important question. So the probability of A or B in general can be calculated by finding the probability of A plus the probability of B minus the probability of A and B together. So in that previous example, the probability of somebody being a Republican or a Trump voter is an example of how we use this formula. We did the probability of Republicans plus the probability of Trump voters minus the probability of a Republican and a Trump voter. If A and B are mutually exclusive, then this formula just simplifies to the probability of A plus the probability of B. And we don't have to worry about any overlap because the two events can't occur at the same time if they're mutually exclusive. So it says if A and B are mutually exclusive events, then they cannot happen at the same time. In other words, the probability of A and B is 0. This is really the same formula. I wouldn't try to memorize it or worry about both formulas. I would focus on this formula right here because this is the one that you're going to use. And then if the events are mutually exclusive, the last part, the probability of A and B, is going to be 0, so it's not going to matter anyway. Let's look at another example here. So it says, using the probability rule for or, what is the probability that a randomly selected person is a Democrat or a Clinton voter? So I'm looking at the chart from the previous example, and let me fill in the numbers here. Okay, so we were looking for the probability that somebody is a Democrat or a Clinton voter. So ask yourself if those are mutually exclusive events. In other words, can somebody be both a Democrat and a Clinton voter? And the answer is yes, they can be both. Somebody can be both a Democrat and a Clinton voter. And so when we use our formula, we're going to have to subtract the overlapping part. So let me go back to the question. So the probability that somebody is a Democrat or a Clinton. So using the formula, that means we're going to have somebody who, so the probability that somebody is a Democrat plus the probability that somebody is a Clinton voter minus the probability that somebody is a Democrat and a Clinton voter. So the probability that somebody is a Democrat, let's look that up. The column for Democrats, there's 821 out of the total. So it's 821 out of the total 2802. The probability that somebody is a Clinton voter, so look at the row for the Clinton voters, that's 930 out of the total 2802 minus the overlap, which is the 502. So minus 502 out of 2802. And if we crunch those numbers, I get a final probability of 1249 out of 2802. So when you see the word or, start thinking about if those events are mutually exclusive. Let's look at the next example. It says, many AP exams consist of multiple choice questions with 5 options. What is the probability of guessing correctly on one question? So I'm gonna call that probability of C for correct. The probability of guessing correctly on one question would be 1 out of 5. So if we make a random guess, we have a 1/5 chance of getting it correct. Part B, what is the probability of guessing incorrectly on one question? So this would be the complement of not getting it correctly. And I apologize, this is terrible notation. I'm going to call this, I'll tell you what, let me get rid of the C instead. Let me go back, I'm going to call this A. So the probability of guessing correctly, we'll call it A. So the probability of getting it incorrect would be the complement of getting it correct. So that would be 1 minus 1/5 or 4/5. Okay, I'm actually going to hold off on part C right now because this involves a concept we haven't talked about yet. So let's go to the next example. If you were to select one card at random from a deck of well-shuffled 52 cards, what is the probability that the card is a heart or a club? So ask yourself, we see the word or, is this mutually exclusive? So how do we know? Can a card be both a heart and a club? And the answer is no. It's either one or the other. So that means these are mutually exclusive events. So to find the probability of selecting a heart or a club, we can just say the probability of selecting a heart plus the probability of selecting a club. So there are 13 hearts in the deck and there are 13 clubs in the deck. So when we add those together, we get 26 out of 52. How about a heart or a queen? So is this mutually exclusive? Can a card be a heart and a queen at the same time? Yes, it can, so that means this is not mutually exclusive this time. So the probability of selecting a heart or a queen is going to be the probability of selecting a heart plus the probability of selecting a queen minus the probability of selecting a heart and a queen. So hearts, there are 13 in the deck. Queens, there are 4 in the deck, so I'm adding those together. Minus, there's one card that is both a heart and a queen, so we're going to subtract that. So when we put these together, this puts me at 16 over 52 for my probability. Last example, a quiz has 30 multiple choice questions. Each question is graded as right or wrong. Incorrect. Correct or incorrect. Suppose the probability that a student makes fewer than, let's see, a student makes fewer than 5 mistakes is 0.34. The probability that a student makes 5 to 11 mistakes inclusive, we'll talk about that in a minute, is 0.18. So we've figured out these probabilities from some sort of experimentation on the test or whatever, so you don't have to worry about where the probabilities themselves are coming from, but we do need to understand what they mean. So I'm going to let X equal the number of mistakes a student could make, okay? So what do we know right now? We know, let's write what we know up here. The probability that a student makes fewer than 5 mistakes. So the probability that X is less than 5 mistakes. So fewer than 5. They can make 0, 1, 2, 3, or 4. That probability is 0.34. The probability that a student makes between 5 and 11 inclusive means we include the 5 and 11. So the probability that we make between 5 and 11 using inequality notation is 0.18. So the probability that they make between 5 and 11, 5, 6, 7, 8, 9, 10, or 11. Part A says, what is the probability that a student makes more than 11 mistakes? So the probability that a student makes more than 11 mistakes. Well, that would be the complement of these other two events, right? So less than 5, between 5 and 11, we want to know the probability they make more than 11. So that would be 1 minus the sum of the other two events. So I'm going to use parentheses to show that sum. And I'm getting 0.48, so about 48% probability. Part B, what is the probability that the student makes 5 or more mistakes? So the probability that the student makes 5 or more. So do you agree that would be, there's 2 ways you could figure this out. You could either say it's the probability that a student makes between 5 and 11, so this 18%, plus more than 11, so 48%. Or you could think of it as the complement of this event, right? If I make 5 or more, that would be the complement of making less than 4. That's probably a little bit faster, so I'm going to do it that way. So that would be 1 minus 0.34, which gives me 0.66. Notice if I had added 0.18 and 0.48, that would be the same value. So there's 2 ways you could have answered that question. Part C, what is the probability that a student makes at most 11 mistakes? So notationally, we can write that as the probability that X is less than or equal to 11, at most 11 mistakes. Well, that would be the probability that he makes less than 5 or 5 to 11. So I'm going to add up the 2 events, 0.34 plus 0.18, and that will give me 0.52. We could have also used the Part A exam, or the Part A section, and just said it's the complement of the event in Part A. In fact, I think that's the next part. It says, what event is the complement of more than 11 mistakes? So they want you to see that Part A and C are complements of each other. So the event of more than 11 mistakes would be less than or equal to 11.